So welcome to the landing video. I won't go through all of our results, but this first one is pretty interesting. This is zinc sulfate. So I have it heating, and I've only been heating it for, maybe 60 seconds, 90 seconds, and it is liquefying. In other words, melting. Here's just a close-up of the melted zinc sulfate. And just one more example I'll show you of one of our materials responding to heat. Evidently, wood kind of darkens or gets black. And just some solubility results. Looks like copper sulfate dissolves, carbon does not dissolve, zinc does not dissolve, copper does not dissolve, salt, sodium chloride, does dissolve, wood does not dissolve, zinc sulfate does dissolve. So super interesting. Without even conducting rigorous, robust, quantitative studies, we're able to start making some grand claims about the nature of reality, about the nature of matter. So number one, compounds bear little resemblance to the elements that make them up. We've talked about table salt, sodium chloride, looks nothing like metallic elemental sodium or gaseous elemental chlorine. But we now see firsthand copper sulfate looks nothing like the elements that make it up, copper, sulfur, and oxygen. And zinc sulfate looks nothing like the elements that make it up, zinc, sulfur, and oxygen. Secondly, and this is harder to tell, but I'll just kind of say it now, and this idea was emerging in the early 1800s, is that compounds made up of similar elements have similar properties. So for instance, sodium chloride is actually very similar in terms of its properties to potassium chloride. And we even saw here that copper sulfate is more like zinc sulfate than it is like copper, one of the elements that make it up. So for instance, both copper sulfate and zinc sulfate responded to heat, but zinc and copper certainly didn't. Both copper sulfate and zinc sulfate are soluble, but zinc and copper are certainly not soluble. So we're seeing this other pattern, kind of emerge, that compounds made up of similar elements are similar, and certainly more similar than the elements that make up those compounds. I hope that made sense. Okay, so keep in mind, this is a radical new way of looking at the nature of matter. The old way, based on the classical four-element theory, was that the properties of substances, of compounds, were based on the amount of elements that made up that compound. So for instance, mud becomes more watery if you becomes more water-like if you add more of the element water to it. Mud becomes more earth-like if you add more of the element earth to it. But we now know that this is not the case. So copper sulfate is a compound, doesn't really take on the properties of copper, sulfur, or oxygen. And in fact, you can't make copper sulfate more coppery by adding more copper to it. You can't make zinc sulfate more zinc-like by adding more zinc to it. And out of this came the idea that when things react, when elements react to form compounds, the compounds are made up of fixed amount of the elements that make them up. But first, the main thrust in the rest of this course will be seeing if there's anything we can say about the relationship between the elements that make up compounds and the compounds themselves, because right now it looks like they're almost completely unrelated. They have share no similar properties. Is there something we can say intelligent about the relationship between the properties of elements and the properties of compounds? And the main window through which we'll do this is studying how compounds react and how elements react, and see if we can make judgments or assessments on what's called chemical reactivity. But before we dive into this, and this is consistent with the history of chemistry and the history of understanding all these ideas, we have to discover more elements. Where are these elements? Where is titanium? Where is gold? Where are all these elements? So let's go see if we can find some elements first, and then we'll dive into studying the relationship between elements and the compounds that they make up.